All right, so we've got this scenario. We've got a company that sets a goal. I'll let you read the whole context, but they set a goal of that their fleet would average at least 26 miles per gallon um, on any given trip. So uh, what we want to do here is we want to go through our process. The first process, or the first part of the process, is state. And in this section, what we're going to do is essentially say, hey, we're going to run a test. We're going to run a test at blank level of significance, and we're going to provide some context as to what that test is going to inform us on. So here's what that looks like. All right, so we'll conduct a one-tailed, and I like to put this detail in there, whether it's one-tailed or two-tailed. You do need to say it at some point. I just usually throw it in this first step here. Alpha level, make sure you specify your alpha level of significance, and then just provide some context. So this says it's a one-tailed hypothesis test at the alpha equal 0.05 level, and we're determining if the fleet average, or in other words, means, of 26 miles per gallon during their trips is being achieved. The next thing we want to look at is hypothesis, or the null and alternative hypotheses. So the null hypothesis looks like this. So we have a population mean of 26 miles per gallon. And the alternative hypothesis looks like this, where the population mean is less than 26 miles per gallon. And this is an important detail. We want to know if they're achieving their goal. If they get over 26 miles a gallon, then they are achieving their goal. So we want to know if, yes, they are achieving their goal, then that would be the null. If they are not, then that means that they're getting under 26 miles per gallon. So this should be a one-tailed test, and the one tail is if their fleet average is 26 miles per gallon. And then the last part is we want to define any notation that we introduced here. So this is kind of quick and simple. We just want to get into this habit. So we just define our mu as the average fuel economy in miles per gallon. So just to reiterate here, a couple important things. We want to provide context for what we're doing here. We're doing we want to detail what kind of hypothesis test, so one-tailed or two, um, and tell the alpha level of that hypothesis test, and then also state essentially what we're going to determine using that hypothesis test. We've got our null and alternative hypotheses, and we want to define any parameters or notation that we introduce. So the next step that we want to do is our plan step, and that's where we're going to check our conditions. So our conditions are these. Number one, was our sample drawn randomly? So we've got 50 trips chosen at random. So the trips were randomly selected. That's good. So that one checks out. We have to have less than 10%. Our sample has to be built on less than 10% of the population. So here we have to assume that 50 trips is less than 10% of all trips. So we're kind of assuming that that works. That one checks out. And then the last one, we got to make sure our sample is big enough. So in this case, we're dealing with means. Our sample has to be bigger than or equal to 30. So we've got 50 trips here. So that one checks out. It's greater than 30. So we can assume this sampling distribution is approximately normal. So we're good. Our conditions check out. Next thing to do is to specify the test and run it and see what happens. So we're on to our do step. And under that do step, we want to specify the test. The test that we're going to run is a one sample t-test for means, for the true mean miles per gallon. So once we specify this test, there are a couple things that we need to make sure that we know. Number one, why is it a t-test? Well, it's a t-test because we don't know the standard deviation. So if we do know the standard deviation, it's always a z-test because we can build our distribution based on that. If we don't know it, we always run a t-test whenever we're dealing with means. So this case, we're given the sample mean and sample standard deviation. We're going to build our t-distribution based on that. And because of that, we got to make sure that we specify some information. So most importantly, we want to make sure that we specify the information that we know. So the first thing is we're operating under the assumption that the true population mean is 26 miles per gallon. And the reason that we say that is because this is how we build the sampling distribution that we're going to test against. So it's going to have a center of 26 miles per gallon. And I always want to include the other information that we're using. And because this is a t-test, there's certain information we need. So number one, our X bar. So we took a sample and we found that sample mean was 24.59 and the sample standard deviation is 4.83. The other thing for a t-test or for a t-distribution that we need are the degrees of freedom. And that is always one less than whatever your sample size is. So our sample size is 50. We've got 49 degrees of freedom. A couple other pieces of info. We want to make sure that we calculate the t-statistic. So the t value here is going to be our sample mean minus the population mean that we're operating under the assumption is the population mean. And then we're going to divide that by the sample standard deviation, 4.83, over root n. So that's how we calculate our t-statistic. And we do need to calculate that t-statistic, or at least show it. We can use our calculator, but we need to at least show the value of that t-statistic. If you go ahead and run this through your calculator, you'll get negative 2.06-ish, right around there. So there's our t-statistic. So we've imported our important stuff, mainly the degrees of freedom that we're going to use for the t-distribution, the actual t-statistic, and then this other stuff. So let's go ahead and use a calculator. So we're going to go to our, this is on the Inspire calculator. We're going to add a calculator, menu, statistics, and we want stat test because we're running a hypothesis test. This particular one, we called it a one sample t-test for means. Under the Inspire, it's simply listed as a t-test. So we want to input stats, hit OK, and here's all the relevant information that we kind of just went over. So I'll go ahead and input that. So here's our relevant information. You can check over that if you'd like. Last piece of info here is, remember, we're doing a one-tailed test, and we want to know if our particular mean, our sample mean, is less than the mean that is claimed, the 26 miles per gallon, because that means we did not achieve our goal. So a one-tailed test, that's our alternative hypothesis. We go ahead and we run the test, and here are the results. You can see it confirms our t value here. So we don't have to do that by hand. If you actually run the test, you could just kind of swipe it off of this. And here is the outcome of the test that we're going to use to make a decision, the p-value of 0.022. So we're back to finish up this do step. Under the test, I've got my p-value recorded down here. And the last thing that we need to do is conclude. So under our conclusion, there are a couple different things that we want to make sure that we specify. First thing that we want to do is we want to compare our p-value to the alpha level and make a decision on our null hypothesis based on that comparison. So this is what that looks like. So you can see we report the p-value, we compare it to the alpha level, and we make a decision on the null hypothesis. The next thing that we need to do is tell within the context of the problem what that decision means. So what that decision means is this. There is statistically significant evidence that the true average miles per gallon for the fleet is less than 26 miles per gallon. So again, we go through this process as state, plan, do, conclude, make sure that we include the important relevant information and do most everything within the context of the problem.